Hello friends, in this video we are going to discuss about the concepts function and recursion. Along with that we will see a few programs that can be using recursion as its logic. Now, what is a function? A function is nothing but a block of code that performs a specific task. So function is nothing but a block of code that performs a specific task. So specific and well-defined task. Why we need to use functions in the program? Because if we are dividing a bigger program into smaller problems and we are making it easy to understand, and we can also reuse the already created program in another program. Okay, so for example, I want to design a human face. In that I want to draw a circles, and each circle should be colored differently. In that case, first I will create a program called circle, and also I will create a program called coloring. So whenever I want to draw a circle, I'll call the function circle, and whenever I want to apply colors to that, I will call the function color. In such situation, I don't need to write the same code again and again and again for entire face, eyes or ears or whatever you want. Okay, so that is the basic idea of using the functions to minimize the work. So next one is types of functions. In C language, there are basically two types of functions. One is standard library function and another one is user defined function. So what is a standard library function? Means it is nothing but a built-in function in the C programming language. For example, in every program we use printf statement, which is used to display the output on the screen, and this is a function, predefined function, and this function is defined inside stdio.h header file, which is a standard input output header file. Similarly, we will use the function. When we were writing quadratic equation, we used the function sqrt. Whenever we used sqrt, we used math.h header file. We included math.h header file in the program because sqrt is a sub function which is defined inside the math.h header file, and which is used to calculate square root of a number. So these are predefined and it will come along with the software. And you can also define your own functions, and those functions are called as user defined functions. Whenever you are writing a user defined function, there are three parts basically. One is called function prototype. One is called function prototype. Function prototype is nothing but if you are using a function, you are declaring it. Just like any variable, you are declaring the function name and what type of data it will return and how many number of arguments it is taking. All these things must be declared before a function is called or defined. That is called function prototype. So similarly, we will have function call. Function, sorry. Second one is function call. From the main program, we can call the function, or from any other program, any other function, we can call another function. So function call is nothing but it's simply having the name of the function along with the semicolon, and if there are any arguments, you are going to write those arguments here. And these arguments must be as per the prototype. As per the prototype, their number of arguments and the type of those arguments must be same as defined in the prototype. So the third one is called as function definition. See, this function definition can be written after or before main function. Function definition. You are going to write what exactly the task will perform. So in this syntax, this is function definition. This is function definition. And this is a function call. There is no function prototype in this syntax because function definition was declared before main function. So you are calling after a definition. You are using this function name after definition. So no need to write function prototype. But it is recommended that you must mention the prototype so that there should not be any error in your any compile. The next one is how the user defined function will work. Always we know that execution of any C program starts from the main function only. When the compiler encounters the function name within the main function, then automatically control will jump from that programming segment to the called function programming segment. So there it is going to that function name, and there it will start executing the code one after the other in the sequential or whatever the way you have written. After completing that block of code or that chunk of code, again the control will come back to the function from where we have jumped to that program. Okay, now let me show you how it will exactly works. See, always function execution starts from main function. So it is executing these two statements. After that there is a function call. Whenever we have a function call, automatically control will jump to that particular function wherever it is written, and it will execute the statements one after the other. After executing the statements, it will come back to the statement after the function call. What are the statements are there after function call? All those statements will be executed. This is how a function will execute. Remember that whenever you are writing a function name, here if you have any parameters, the number of parameters and its data type must be same for the this function definition header as well as for the function call also. Here you don't need to write the data types. You just need to mention the arguments either as a variables or as constants. So these parameters are called as actual parameters and these are called as formal parameters. Actual parameters are nothing but which are declared inside the function call are called actual. Okay, now go to the next one. Why we need functions, user defined functions. So whenever you are dividing a bigger problem into smaller problem or a smaller task, then it is easy to understand, easy to write, easy to debug, and easy to maintain as well. So that is the first use of writing the programs. And second one is reusability. Reusability means once I wrote the program, automatically I can use that program any number of times. I'll give you a small example here. Let us suppose there is a car company. That car company is not manufacturing the tires, right? So tire manufacturing company is different. A car contains four wheels or a bus contains four wheels. A vehicle manufacturer is different. A tire manufacturer is different. So when I want those tires, I can order for four tires or three tires from the tire manufacturing company. Means I am reusing whatever they have already created. So that is the easy method. Instead of doing everything from scratch, we can get it from somewhere which is already available. That will reduce the burden of doing each thing from the scratch. So a large program can be divided into smaller modules. Hence, a large project can be divided among many programmers so that easily we can complete the task within the given time. So now I would like to explain the most important concept called recursion. Recursion is nothing but a function if it is calling itself, then that is called as recursive function. If a function is calling itself many number of times, then that function is called as a recursive function, and the technique is known as recursive technique. If you see in this code, recurse is the name of the function. It is not returning any value and it is not taking any input. So within this recursive function, we are calling the recurse. Means again we are calling the same function again and again. So initially, always the program execution starts from the main function. After execution starts, it will execute this statement. After that, we reach the recurse function. So from here, we are going back to the program, the block where that actual code is existing. So in this, again it is executing statement one by one. So when it is executing, again we reached one more time calling the same function. So from here we are going back to this beginning of the code. When I will reach this particular statement in the sense, for that you need to have an ending or base condition. That base condition is nothing but which says when to come out of this looping or recursion. So this is done, and for that you have to use either if else statements or similar kind of approaches. So that is called as base condition. So base condition means you are branching, you are deciding when to stop that recursive call and when to come out of that recursive function. Now the question is, write a program to find the factorial of a given number using a recursion. Now, first of all, let us understand what is factorial. So, factorial is nothing but n factorial equals to 1 into 2 into 3 into 4, etc. up to n numbers you are multiplying. That's it. And when you are using factorial of negative number, that does not exist. And moreover, if you are giving n value as 0, then the answer is 1. So there is some formula like n into n minus 1 factorial. You can write something like this, which is nothing but if you have given n value as 3, let us suppose, I can directly say it like 3 into 2 into 1. Or else I can also use this formula where I will say 3 into 2 factorial. 2 factorial. What is 2 factorial? It is nothing but 3 into 2 factorial is called as 2 into 1 factorial. So what is 1 factorial? So 3 into 2 into 1 factorial is nothing but 1. So into 0 factorial, let us suppose. I have reduced it into 0 factorial. So we know that factorial 0 is nothing but 1. So that says that 3 into 2 into 1 into 1. So that means 1 into 1 is 1, 1 into 2 is 2, 2 into 3 is 6. The final answer is 6. This way it will also work. So this formula we are going to use for our recursive method. So now see the program. This is called function prototype. This is called function prototype. The name of the function is fact. Name of the function is fact. And the parameter or the input it is taking is integer number, and it will return a long integer. It will return a long integer. Okay. So in the program we are going to read the n number. N is any positive integer. After that we are calling the function. This is called as function call. Function call. And this is called as function prototype. Prototype must be declared, and it can be declared either as a global variable or it can be declared as a local variable. Okay, so either this place you can write your function prototype or here you can write your function prototype. So main program is simply reading the positive integer and then it is calling the function, and because I said function is going to return long int, we are using LD here. Okay, what is there in the recursive function? Let us see that. So, first I am checking whether n is greater than or equals to 1. As I said, n is equals to 0 in the sense factorial value is 1. So, if n is equals to 0, we are returning 1. N is less than 0 means a negative number in the sense there is no factorial. So, if n is less than 0, I will return 1. This is the base condition. Otherwise, what I am doing here is n into n minus 1 factorial I am doing. So, here fact of n minus 1 means it is calling this same function. Let us suppose initially it is 4, then it is calling with 3. Okay, when it becomes 3, it is calling with 2. When it is 2, it is calling with 1. So, when it is 1, it is calling with 0. Okay, so we know everything. N into it is happening. So, this way it will work. Let us see this in the compiler. Execute and see this in the compiler. Now it is asking a positive integer. So here I am giving the positive integer as 4. I want to calculate 4 factorial. 4 factorial is nothing but 24 it has to show me. See this. Factorial of 4 is equals to 24. Okay. So this is working absolutely fine. Now let us see the next one. The next question is to find the GCD of given two numbers. So GCD is nothing but greatest common divisor of two numbers. So what is GCD? A number that divides the both numbers. Then that number is called as greatest common divisor of those two numbers. So for this program we have to take two positive integers as input and then we have to calculate GCD. See this, here I am declaring a function called integer find GCD int comma int means I need to take two input values and the name of the function is find GCD and the data type int. This data type says what value, what type of value that function is returning to the calling function. Now in the main program, we have declared two variables a and b for input purpose and we are declared another variable ACD for output purpose. And we are we are reading a and b values using the scanf function because a and b integers we are using percentile d for two numbers individually. After that we are calling the function. So this is nothing but calling of a function. We are calling the find GCD and this function will return an integer value and that integer value will be here. So that will be displayed here because that is integer. So we are using int percent %d for this d and this percent %d we are writing for a and this percent %d we are writing for okay. So now in the recursive function what we are doing, see I am taking two variables y which will store the input data. So I am checking whether x is greater than y. I'll call the function with x minus y and y. If y is greater than x, I am calling the function x comma y minus x. Otherwise, I am returning x as its value. I'll tell you with an example. See, I am taking x value as 40 and y value as 21. There are three cases, whether x is greater than y, greater than x or x is equals to x. So first let us check. X is greater than y. I am checking this condition. So initial value of x is 14 and y is 21. This condition is false. Because this condition is false, I have to go to the else part. Else part is checking is y greater than x. So in this case, 21 is greater than 14. Yes, this is true. When this is true, what we are trying to do is we are calling the function with x comma y minus x. So x is nothing but you are calling GCD with x value. What is x value? 14. 14 will be as it is. And what is y minus x? Means 21 minus 14. What is the value? So you are sending 7 to that. 7 to the as the second value. Now it is went to the GCD of x comma y. Hope you are able to follow me. See this. Here I did this. Here I got 14 here and this is 7. So we are calling the function. So this will go here and this number will go here. That means next time x value is 14 and y value is 7. Okay. So now x value is changed. Now x value is 14 and y value is 7. Now again we are checking. Next time 14 is greater than 7. Is it right? Yes, this is true. So because this is true, this function is true, we are executing this one. We are going to execute this one. So GCD of, we are calling with x minus y. So 14 minus 7 is 7. And next one, y is already as it is we are sending. We are sending 7 comma 7. So next time this is 7. Y is as it is. Now again you are coming and checking. 7 is equals to 7. Yes, you are retaining the value of 7. So greatest common divisor which divides 14 and 21 is 7. That is the answer. Now let us see the same thing in the compiler. Let us compile and check the program. Now let me run the code. It is asking two numbers. First one is 14 and second one is 21. Whatever I explained you, the same numbers I am giving as input so that we can check whether the output what we expected is right. Yes, GCD of 14 and 21 is 7. So this program is absolutely correct. So now let us go to the next one. This time they are asking us to find or to print the Fibonacci series using recursion. Now let us understand what is Fibonacci series. Fibonacci series is nothing but each number is the sum of its previous two numbers. Every number is generated by adding its previous two numbers. Then what is the starting numbers in the sense 1 and 1 are the starting digits. So that let us suppose initially I am having 1 and 1. Now I have to add these two numbers so that I will get 2 as the next number. Then again I am going to add 2 plus 1 which is 3 next number. So next number is 3 plus 2 which is 5. The next number is 5 plus 3 which is 8. So like that, the series will be generated. So this is what they want us to do using recursion. So for that, what we are doing is initially we are declaring the header file what we want, and then we are declaring the function prototype. So this function name is Fibo, and it will take one number. It is this number is nothing but how many numbers you want to generate. So in this case, 1, 2, 3, 4, 5, 6, 7. Let us suppose 6 numbers I want to generate. Then you are taking that as input, 6 as the input here, and what it is returning is nothing but in the function itself we are going to print all the generated numbers. So it is not returning any value result back to the main function. Okay, so void means nothing, not even 0. Now see the main function. In the main function, we declared a variable k and n, and also we are declaring the long integer data type variables I and j. Now we are reading the value of n. What is n? Nothing but the input. How many number of sequences you want to print. So after that, what we are printing here is we just want to print 1. We want to print the first number as 1. Okay, so after that we are calling the function along with the given input number. So what happens in the recursive function is nothing but in the Fibonacci number I am taking two variables, first number and the second number. Here I am taking the first number as 0 and second number as 1. Okay, so I want to add those two numbers and store in sum. Now I'm checking whether whatever you have entered as an input is greater than 1 or not. If it is greater than 1, then only I'm going to do this one. Otherwise, I'm simply coming out of the program. Okay, so let us suppose I have given 6. So first number 0 plus 1 is added, and now sum contains 1. Initial sum is already we have printed 1, right? So now we have one more 1 here. Output was already printed 1 because in the main program we have printed that, if you remember. See here we have printed 1. So already output is having 1 1, and now sum is having 1 now. What is first? First is nothing but whatever is there in the second. So now first contains 1. Now what is second? Second is going to store whatever is there in this number. That is also 1. So now we are printing the sum, which is nothing but 1 is printed. Now again we are calling the Fibonacci number with n minus 1. N minus 1 means already 1 is printed. So we are going to call it with one more time, this time as 5. Okay, so 5 is greater than 1. So again you are coming here. This time you are adding 1 plus 1. First become 1. So 1 plus 1, which is equals to 2 now. So now sum contains 2. And now we are changing first as second number, which is nothing but 1 only. Second is having the sum, which is nothing but 2. And now we are printing the sum value, which is 2. Again you are calling the function with 4. So like that we are going to print 6 numbers on the screen. Okay, so this is the code. Let us execute the same code in the compiler. Let us generate the Fibonacci series. Running the code, it is asking for how many number of series you want to print. I want to print 6 numbers. So it is printing up to 8. 1, 1, 2, 3, 5, 8. 1, 2, 3, 4, 5, 6. 6 numbers it is printing. 6 sequential numbers it is printing. So this function is working. Recursive function is working. The next question is sum of list of elements using recursion. That means in this situation we are going to use an array. Array is nothing but a collection of same type of elements stored under a single name. So here we are going to pass an entire array as an argument to a function. Normally, a function can have 0 arguments, 1 argument, 2 argument, 3 argument, or n number of arguments you can send. But array in the sense it is a collection of values. All these values one by one also you can send, but I want to send it as a whole, complete array I want to send. So when you are sending a complete array as an argument to a function, in that case you are going to write two arguments. One argument is the name of the array. So why we are writing name of the array in the sense, whenever you are saying array, the array name is nothing but it is having the base address. Let us suppose the address is 200 here. So like that I am having n number of values. Let us suppose all the values of integers in that. Then integer occupies 2 bytes. Let us assume. Then the next address will be 202. 202. The next address will be 204. Like that it will be having 206 and then 208. When you are declaring, let us suppose int a of how many number of digits? 1, 2, 3, 4, 5. So if I declared 5, if this is specifying this block. If I say simply A is nothing but the name of the array. This name of the array is nothing but the pointer to the starting address of this block. So that is called base address. So when you are sending the argument, you are sending the name of the array so that it will point to this address. Along with that, you are also sending the size of the array so that it can calculate and go up to the last boundary. Okay, so that it cannot go beyond the boundary. Okay, so next thing, see the program. In the main program, here I am declaring the header file. After that I am writing the function prototype. If you observe, sum is the function name. Sum is the name of the function. It is taking two arguments. One argument is nothing but the array name and the second one is the size of the array, and this is called the return data type, and the return data type is also you are going to calculate the sum of all the integers in an array, so it is also an integer. So in this program I have declared and initialized the array at a time. So here I am mentioning the size of the array. When I need to mention the size, compiler will automatically calculate based on the number of values you have provided and also based on the data type you mentioned. And also we are declaring n. N is nothing but the size of the array. Okay. So how I am going to calculate the array? Using size of a by size of a of 0. Size of a means, let us suppose how many elements are there. So 5 twos, each element occupies 2 bytes. So size of the array is 10. And what is the size of a single element is 2 bytes. So how many elements are there now? Total 5 elements are there. So this is the size of the array and you are calculating using this. Size of is an operator which will give how many number of bytes the specified argument will occupy. Okay. So here we are calling the function. When you are calling the function, you are simply mentioning the name of the array. See, here I have used square brackets. It is necessary here. But here, no need to write the square brackets. This is function call. In function call, you don't need to write the square brackets. And then you are also sending the size of the array. Make it a point when you are declaring at the prototype, that time you have to mention the square brackets for sending an array to the function. When you are calling the function, you don't need to write the square brackets. you simply write the name of the array so that it is pointing to the starting address of the block. In the recursive function, what we are doing is, here I mentioned the size of the array. So here I am checking whether n value is less than or equals to 0. If n value is less than 0, I don't need to calculate anything. So I will simply send 0. Otherwise, what I am doing here is, I am calculating sum a of n plus 1 plus sum of a comma n minus 1. So let us suppose I am having an array and it is having the values 1, 2, and 3. Let us suppose these are the numbers. So here the size of the array is 10, but I am using only 4 elements. Okay, size of the array is only 4 now. Okay, it is checking 4 is less than or equals to 0. No. So it is coming to this statement. So here we are having a of n minus 1. N is 4. So 0 is the index of the first element, 1 is the index of second element, 2 is the third element, fourth element index is 3. So you are taking a of n minus 1. 4 minus 1 is nothing but 3. A of 3 position, what is the value? Is nothing but 3. So 3 plus, you are writing 3 plus this sum. So you are calling the function with n minus 1. So what is n minus 1 here? This becomes 3. Now you are checking 3 is less than or equals to 0. No. So again you are coming here. You are taking a of 3 minus 1. 3 minus 1 is nothing but a of 2. A of 2 is having 4. 4 plus, again you are calling the function with 3 minus 1, that is 2. So it is going and checking 2. So again you are coming and checking 2 is less than or equals to 2. No. So it is coming here. It is taking the next element to 2 and then it is calling with 1. So this time n value becomes 1. It is checking 1 is less than or equals to 0. No. So again we are coming here and adding this 1. And also we are calling the function a with 0. When it is going here, this becomes 0 and again you are coming here and checking is 0 less than or equals to 0. Yes, it is coming here. By that time we have written, what we have written is 3 plus 4 plus 2 plus 1, which is nothing but 10. 10 is written to the main function. So now let us see the same coding in the compiler. Now I am executing the program. So it is giving the value because we have given 1 plus 2 plus 3 plus 4 plus 5 it has to do. So 5 plus 4 is 9, 9 plus 1 is 10, 10 plus 3 13, 13 plus 2 15. So 15 is printed here. Okay. So this is how the programs will execute. First thing you have to understand how to write a recursive program. Then automatically you can able to write any of these recursive functions. Only thing that you are trying to learn is how to write the base condition. Once you know how to write a base condition, you can simply write the coding and then you can say whether it is working or not. You can easily understand the logic. Okay. Hope you have understand recursive and recursive programs as well.